Okay, we're going to do a review of trigonometry, and there are like 8 questions on ALEKS of varying types that you need to do. So I'll give you an overview of what you need to know. I believe you're going to need to know the Pythagorean theorem. So x squared plus 6 squared equals 15 squared. The order of the legs doesn't really matter. Doesn't matter which one of those you put first or second, but this one has to be by itself. And this is called the hypotenuse. It's actually a Greek word, and if you translate the Greek word into English, it turns out to be something like an occupied toilet on a mountain. Katie got it. An occupied toilet on a mountain. A hypot in use. Okay. It wasn't funny. Don't patronize me. I would, but it'd be TVMA and you wouldn't be allowed to watch it. Okay. So here we just use our algebra to solve. This is 225. This is 36. So 225 minus 36 is 189. Take the square root, and I get the square root of 189. Now, you do have to check to see if 189 simplifies. Well, do I need plus or minus? No, because side lengths are always positive unless you're in the coordinate plane, which we're not. So 189 is divisible by 3. 3 and 63. So 3, 3, 3, and 7. Can I pull anything out? A 3. So it is 3 root 21. Okay? All right. So what if I called this angle A, and I asked, what is the sine of angle A? So TOA. So it would be this divided by that, which is 3 root 21 over 15. That simplifies down to root 21 over 3, or 5. So the sine of A is root 21 over 5. Okay, now, what if it asked for angle A? Now, I probably wouldn't use this because it's a little more complicated. But if I said angle A equals what, that's when you do the inverse sine or cosine. So you could do cosine, you could do sine, or you could do tangent. I'm going to choose cosine because I don't want to plug a square root into my calculator. So I know that the cosine of A is 6/15. So I invert that, and I get the cosine negative 1 of 6/15 is A. And then I just ask my calculator, what is the cosine inverse of 6/15? And what's wrong? That certainly isn't a 1.15 degree angle. My calculator is currently in radians. So I'm going to push mode, go down to degree, and degrees make more sense in the real world. Like if you're going to measure something, you want to use degrees. But if you're going to graph sine and cosine, or if you're going to do anything theoretical, radians make way more sense. So in the pretend world, radians are our choice, but in the real world, degrees are much better. So this angle is a 66-degree angle. What's that? Well, if I wanted to graph, so if I graph the sine wave, it looks like this, right? Well, the x-axis is in degrees, and the y-axis is in whatever unit you're working with, inches or feet. Or so if you're talking about how light travels through space, these measurements are degrees. If you attempt to do it in degrees, you'll say, okay, walk 3 degrees and go up 6 inches. Well, how far is 3 degrees? It's not a distance, it's a rotation. So you actually cannot represent this in degrees in the physical world. So what we do instead is we take, instead of measuring rotation like this, we actually take that length and we duplicate that length in this direction, and we call it radians. That way we know exactly what the graphs look like. So radians allow us to graph the sine, cosine, and tangent. Now, you can graph them in degrees, but you're really just guessing what the x-axis looks like. Right? There's no distance attached to it unless you do that in radians. So degrees are a rotation. Radians are both a rotation and a distance at the same time. So we have to have radians in order to accurately graph sine, cosine, and tangent. So anyway, that's why we do it. Okay, I think there's really only one type of problem left. So let's say you're standing here and you're measuring, what color are trees? Green? Usually. Hey, this is kind of fun. This is a remembrance of a sunnier time. Okay. All right. So let's say you're standing outside. You want to know how tall a tree is. You are standing 12 feet from the tree. Your eye is 60 inches off the ground, and you're using some kind of angle measuring device, and you figure out that angle is 38 degrees. How tall is the tree? So I could convert this into feet. 5 feet. So I'm going to stick that here. And this is 12 feet, and I need to find x. What 2 sides am I using? Adjacent and opposite, which is tangent. So I set up the fraction. The tangent of 38 is x over 12. How do I solve that? Multiply by 12. And the answer is 12 tangent 38. So 12 tangent of 38. And that tells me that's the height of the tree above your eye. So I need to add the 5 feet to it. And I get 14.375. A smarter physicist would put you on the tree and push you off. Because a 14-foot fall, probably not deadly, but it's going to hurt. Okay, so when you're solving these equations for trig ratios, there are really only 2 types. The first is x is on top, and we multiply by 12. But what if you wanted to know how far is it from my eye to the top of the tree? Well, let's use cosine. So the cosine of 38 is 12 over y. How do you solve these? So here's the long way. You multiply by y, and then divide by the cosine of 38. Okay, that's the long way. Here's the faster way. You just swap places with those. And you get y equals 12 over the cosine of 38. So I refer to these as a multiply problem or a switch problem. And the switch does essentially the same thing as multiplying both sides by y and then dividing by the cosine of 38. Okay? I believe that's everything you need to answer those 8 questions, and you have 2 copies of each type on your assignment. So 16, good job. Way to go. If I had a gold star, I'd 8 types, 2 of each. If I had a gold star, I'd probably get it to Addie for having to sit by you. Okay, get to work.